Hello, 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 everyone, and welcome back. We're up to question 15 now on the 2007 Cayley Math Contest. In the diagram, triangle ABC and triangle PQR are equilateral. Okay, whoa, what's going on in this diagram? So, got ABC here, and then PQR here. I think I'm going to use different colors when I draw my diagram, but they're equilateral. And I noticed down here we were given some other angles, so I think we're probably going to use the fact that equilateral triangles have an interior angle of 60 at every corner. But let's finish reading the question. So they're equilateral. We're being asked, what is CXY? So that's CXY. All right. Well, let's get to drawing this diagram, and we're going to separate our two triangles with different colors, shall we? That'll make things a little more readable. So what exactly do we have? We have 65, then 75, and the two triangles are sort of leaning into each other a little bit. Just a little bit. And that doesn't look like an equilateral triangle, so we'll draw it again. Much better. So that's A, B, C, and then we've got there's P at the bottom. Oh, sorry, I've got my A, B, and C backwards. Well, at least my A and my B backwards. P, Q, R. And we've got X and Y down here. Now, I did say I was going to use different colors, didn't I? We'll use the blue for our other triangle. And there we go. And let's clean it up a little bit in here, because I feel like we're going to have to deal with some of the angles in here. Okay. So, we want this angle here, CXY. Now, I can tell you right away that we got 60 degrees here, 60 degrees here, 60 here, 60 here. They told us 65 degrees here and 75 degrees here. I think quite critically, we've got a 60 degrees in here and a 60 degrees in here. All right, what can I do? Well, I know I've got a straight line here, so I can figure out this angle, and I can also figure out this angle. From those two, I think I can figure out this angle, and then I can get this angle because it's opposite in a transversal. When two lines cross, opposite angles are equal. So I've got a plan of attack. I haven't made a single calculation. I just sort of have a plan of attack, and that's a great thing to do when you do questions like this, which are what I sort of call diagram chasing. We're trying to find an angle hidden amongst a whole bunch of other possible angles to calculate. We could go through and just, oh, I'm going to try and get this angle, and ooh, it looks like I can get this angle over here. But unless we have a plan of attack, we can waste a lot of time. Okay, so we want to focus in, find the angle that we do want, and say, what angles would I need to get this? What angles would I need to get this? And then attack from the other side and say, what angles are immediately apparent at the start of the question? Because, yeah, we could mess around with a few angles, and this question isn't going to take very long. But imagine that it's next year and you're writing the contest, and it's a Fermat paper. And it's got even more triangles, and you're stuck, chasing a whole bunch of angles that won't lead you anywhere. Having a plan of attack can be quite a lifesaver here. Okay? And that's what we've got here. So, 65, 60, this is going to be 55 degrees. 180 minus 60 minus 65, it's going to be 55. Another way, I'm doing this in my head because 60 is the average. It's when I take 180 divided by 3, I get 60. So, however much more than 60, 65 is, the other angle is going to have to be that much less. Similarly here, 75 is 15 more than 60, so our other angle in here is going to be 60 minus 15, 45. Okay, 45 and 55 add up to 100. So this angle here at Y is going to have to make up the rest, because remember the sum of the angles inside a triangle forms 180 degrees. 55 and 45 make 100. So here we get our other 80. And now, because opposite angles are equal, we get 80 degrees here. And now let's just zoom in on this triangle for a second. So we get, let's zoom in a little more. And let's actually use our colors, shall we? We got time. Let's make this nice and pretty for everyone to see. So they were sort of zooming in there. So we know we've got 80 degrees here, 60 degrees here. This is C, this is Y, this is X. And we want our green angle here. Well, we know 180 degrees is the sum of the angles inside a triangle. I've got 60, I've got 80. If you need to use your calculator, that's fine, but those two add up to 140. What's left? 40 degrees. So CXY, and I'm going to double check that this is the one they asked for and not CYX. But CXY is 40 degrees. Fantastic. So is that one of our possible answers? And we do want CXY. I'll clean up my diagram just so I can double check that X is where I think it is. Yeah, we're good. So our answer is C, 40, and that will wrap up question number 15. Thank you so much for watching. Feel free to like or subscribe to be kept up to date. But either way, I will see you guys for question 16 in the next video.